MP Balan, Assistant Professor, Department of Civil Engineering, Rogini College of Engineering and Technology. Flat slab. Flat slab is a reinforced concrete slab supported directly by concrete column without use of beam. Okay. Flat slab is a reinforced concrete slab supported directly by concrete column without use of beams. So flat slab problem: design a exterior panel of a flat slab for system for a warehouse 24 meter into 24 meter divided into panels of 6 meter into 6 meter. Live load is 5 kilonewton per meter square. Column size 400 mm diameter and M20 grade concrete Fe 415 steel. Height of story is 3 meter. Thickness of slab in column strip is 300 mm. Thickness of slab in middle strip is 200 mm. Step 1: dimension of flat slab. Thickness of slab in column strip is equal to 300 mm and thickness of slab in middle strip is equal to 200 mm. First find out the column head diameter. So column head diameter is equal to formula 0.25 into L. So 0.25 into 6. So that is the panel size, 6 meter. So column head diameter is equal to 1.5 meter. Length of drop. The length of drop is equal to L divided by 3. So L is nothing but size of panel length. So 6 meter divided by 3. Therefore length of drop is equal to 2 meter. Then drop width. Drop width is equal to 1.5 into 2. Therefore 3 meter. And the column strip are also equal to drop width is equal to 3 meter and width of middle strip is equal to 3 meter. Then step 2: stiffness stabilization. The stiffness of column Kc is equal to 4 EI by L. So 4 into E into 400 the whole power 4 divided by 64 into 3000. So I is equal to moment of inertia, that is the 400 whole power 4. Therefore stiffness is equal to 1.67 into 10 power 6 G. The column both at the top and bottom, stiffness of column K is equal to 2 into 1.67 into 10 power 6 G. The stiffness of slab is given by stiffness of slab K is equal to 4 EI by L. Therefore answer is 9 into 10 power 6 E. And alpha C, refer IS 456-2000 page number 56. Alpha C is equal to Kc divided by Ks. So substitute the value for Kc divided by Ks. So Kc is nothing but stiffness of column and Ks is nothing but stiffness of slab. So alpha C is equal to 0.37. Then ratio of L1 divided by L2. So refer IS 456-2000 in page number 56, table 17. So L1 1 and L2 1. Therefore ratio of value 1. Therefore alpha C minimum is equal to 0.7. Then step 3: find load. Live load is equal to 5 kilonewton meter square, that is the given, and dead load is equal to length, breadth, overall depth and density of concrete. So substitute all value in formula. Therefore dead load is equal to 6.25 kilonewton per meter square. and floor finish assume 0.75 kilonewton per meter square. For total load is equal to live load plus dead load plus floor finish. So answer is 12 kilonewton per meter square. Next, factor load WU is equal to total load into factor of safety. So total load 12 and factor of safety 1.5. Therefore factor load WU is equal to 18 kilonewton per meter square. And step 4, find bending moment. So bending moment M is equal to formula WLN by 8. That is the refer IS 456 2000 in page number 55. So Ln is equal to formula L minus 1.5. So 6 minus 1.5. Therefore Ln is equal to 4.5 meter. So W is equal to WU into L2 into Ln. So all value you know. So find out the W. So finally find out the total moment. So total moment M is equal to WLN by 8. So substitute the all value. And M is equal to 274 kilonewton meter. Then next, interior negative design. So refer IS 456 2000 page number 55. So formula 0.75 minus 0.1 divided by 1 plus 1 divided by alpha c in the M. So substitute the all value. So interior negative design is equal to 194 kilonewton meter. The interior positive design. So interior positive design is equal to 0.63 minus 0.23 divided by 1 plus 1 divided by alpha c in the M. So interior positive design value answer is 141 kilonewton meter. Then exterior negative design. So an exterior negative design is equal to formula 0.65 divided by 1 plus 1 divided by alpha c in the M. So if exterior negative design answer is 73 kilonewton meter. Exterior negative design is interior negative design is column strip is equal to 75% of bending moment and middle strip is equal to 25% of bending moment. So column strip for answer 146 kilonewton meter and middle strip answer 48 kilonewton meter. The exterior positive design is equal to column strip 60% M and middle strip 40% M. So 60% M substitute the value. So column strip answer 85 kilonewton meter and middle strip is 56 kilonewton meter. Then exterior negative design, column strip is equal to 75% in the M. So answer is 55 kilonewton meter and middle strip is 0 kilonewton meter. Then step 4, check for thickness of slab. So thickness of slab D is equal to root of mu divided by 0.138 into FCK into B. Substitute the all value. So find out the required effective depth. So effective depth is equal to 133 mm. Thickness of slab at a near drop, that is the column strip. So that is the D is equal to 133 mm. And thickness of slab at middle strip. So middle strip answer D is equal to 83 mm. Substitute the all value. So find the D is equal to 83 mm. Thickness of slab near drop column strip is equal to overall depth that it drops D is equal to 300 mm. So find out that is the overall depth. So find out the effective depth. So effective depth is equal to overall depth minus effective cover. So assume effective cover 30 mm. Therefore 300 minus 30. So effective depth is equal to small d is equal to 270 mm. So next, thickness of slab at middle strip. So thickness of slab at middle strip, first of capital D, overall depth at middle strip is equal to 200 mm. So find the effective depth. So effective depth small d is equal to 200 minus 30. So 30 is nothing but that is the effective cover. So small d is equal to 170 mm. And next, check for shear stress. So check for shear stress. First to find out the total load on circular area. So circular area, total load on circular area, so W is equal to by 4 into capital D plus small d the whole square into WU. Okay. So capital D is the column strip plus small d is the effective depth into WU. Okay. WU, that is the factor load. So substitute the all value. So find out the W. So W answer is 44.3 kilonewton. Then shear force is equal to total load minus load on circular. So total load 18 into 6 into 6 minus total load on circular is equal to 44.3. For shear force is equal to 603.7 kilonewton. Then shear force per meter of perimeter is equal to shear force divided by capital D plus small d. Capital D is the is not a overall depth, so it is the column strip capital D. Okay, plus small d is the effective depth. So substitute the all value, find out the shear force per meter of perimeter. So answer is 340.66 kilonewton. Then shear stress dou V is equal to shear force divided by B into D, that is the cross sectional area. So substitute the all value, find out the dou V value 0.42 Newton per mm square. Then permissible shear stress. So permissible shear stress formula, refer IS 456 2000, page number 58 and 59. The Ks formula 0.5 plus beta C. So beta C is equal to L1 by L2. So substitute the all value. So first to find out the beta C, that is the L1 L2 is nothing but size of panel. Size of panel is 6 meter into 6 meter. So 6 by 6 1 meter. 6 by 6 1. Okay. Then Ks is equal to 0.5 plus 1. Okay. So then dou C formula 0.25 into FCK. So 0.25 into concrete grade 20, therefore 1.118 Newton per mm square. Then permissible shear stress Ks into dou C. Okay, Ks value 1 and dou C value 1.118. Therefore permissible shear stress value 1.118 Newton per mm square. So check for the permissible shear stress and shear stress. So hence it is safe. Then finally find out the reinforcement, positive and negative reinforcement. So positive reinforcement, refer AST, area of steel in tension reinforcement. So refer IS 456 2000 in page number 96. So formula M is equal to 0.87 FOAST into D 1 minus FAAST divided by BD into FCK. Therefore mu is equal mu value 146 into 10 power 6, that is the column strip negative bending moment value substitute. So balance value, all value substitute, then find the AST. So AST is equal to answer 475.33 per meter. Okay. Next, spacing of rod. So spacing of rod is equal to small AST divided by capital AST into 1000. Therefore answer is 237.240 mm. Provide spacing 240 mm. So provide 12 mm diameter bar at 240 mm center to center. And distribution reinforcement is equal to 0.12 divided by 100 into breadth into depth. So AST distribution is equal to 1080 mm square. Okay. So then per meter length 1080 divided by 3 meter. So per meter length area is equal to 360 mm square. Provide 10 mm diameter bar. So spacing is equal to 1000 into small AST divided by capital AST. The spacing is equal to 280 mm. So similarly find out the middle strip for negative and positive bending moment. So same formula for IS 456 2000, page number 96. Substitute the all value, only different for mu middle strip bending moment value. So AST is equal to 229.08 mm square. Therefore, then next to find out the spacing. So spacing is equal to 493.7, so rounded value 300 mm. So provide 12 mm diameter bar, 300 mm center to center for both positive and negative bending moment. Next, AST distribution. AST distribution 0.12 divided by 100 into B into D. So AST distribution is equal to 720 mm square. Therefore AST per meter length, so 720 divided by 3, therefore 240 mm square. Then spacing is equal to 1000 into small AST divided by capital AST. Therefore spacing is equal to rounded 300 mm. So provide 10 mm diameter bar at 300 mm center to center, both positive and negative moment. And finally check for deflection control. So deflection control, the PT is equal to 100 AST divided by B into D. So that is the PT is nothing but percentage of steel, 0.134, and modification factor value 1.8. Then finally L by D max is equal to modification factor into 26. 26 nothing but basic value. Okay. And LBD provided span divided by depth. So LBD maximum value answer 46.8 and LBD provider answer 35.2. So LBD maximum is, and LBD provider is greater than. Okay. So hence it is safe. So thank you.